First of all, congratulations because you have made it to your last video lesson for Geometry Semester 1. So if we were to talk about a 45, 45, 90 triangle, recall 45, 45, 90. Its sides are 1, 1 and square root of 2. So if I were to list the ratio of the leg to the leg, it would be 1 divided by 1. If I were to list the ratio of the leg to the hypotenuse, it would be 1 divided by the square root of 2. For a 30, 60, 90 triangle, our sides are 1, 2, and square root of 3. The short leg is 1. The long leg is square root of 3. And the short leg to the hypotenuse would be 1 to 2. We can use these ratios to help us figure out angle measures and to help us, if we have angle measures, figure out missing sides. And we're going to be learning what are called the three trig functions: sine, cosine, and tangent. The sine of an angle is defined as the ratio of the opposite leg length to the hypotenuse length. And in a little bit, I'm going to go in depth into explaining what exactly that means. Just to give you an idea, it's if I had a picture of a triangle and I was looking for the sine of this angle, my opposite leg would be this one and my hypotenuse would be this one. So I could say that the sine of this angle is equal to opposite over hypotenuse. And again, we're going to talk about that more in depth momentarily. So for now, we're just going to learn how to put this in the calculator so we can find the sine of 42. So there's a button on your calculator that says sin. That does not actually mean sin, like something you do wrong. It's short for sine. And we're going to be utilizing sine, cos, which stands for cosine, next to it, and tan, which stands for tangent, which is next to that. Before we can use any of those, though, I need you to do something. You need to go to your calculator. You need to go to mode. And you need to change from radians. You need to change from radians to degrees. Your calculator must be in degrees for this quiz. So we're going to type in the sine. Once that's done, go back to the main screen and type in the sine of 42. And when you type in the sine of 42, it should give you 0.67. Then we're going to do the same thing and do the sine of 20. And our sine of 20 is going to be 0.34. So the cosine of an angle is the ratio of the adjacent leg length to the hypotenuse length. To give you a picture, so if I had a triangle and I wanted the cosine of this angle, I would use the adjacent, which means next to side. So this would be my adjacent side, and this is going to be my hypotenuse. So the cosine of a 42-degree angle, again, we can just use our calculator. So you can hit the cos button, and we're going to do cosine of 42. We don't have to change the degrees we don't have to change into degrees because we're already in degrees. The cosine of 42 is going to be 0.74. And the cosine of 20 is going to be 0.93. The last is the tangent, and the tangent of an angle is the ratio of the opposite leg length to the adjacent leg length. So if I have a picture of a triangle, here's my angle. The opposite is the one across from it, and the adjacent is the one next to it. So I could use those two to help me find the tangent. So the tangent of 42, just have to type that in my calculator. Tangent, we use the button that says tan. The tangent of 42 is 0.90. And the tangent of 20 is going to be 0.36. So we're going to use this phrase to help us remember sine, cosine, and tangent. So I want you to write the phrase SOH, S-O-H, CAH, C-A-H, TOA, T-O-A, SOHCAHTOA. SOHCAHTOA is going to help us remember what we're trying to find, what we're doing sine, cosine, and tangent. So what they stand for is this says that the sine of some angle is equal to the opposite side over the hypotenuse. The cosine of an angle is equal to the adjacent side over the hypotenuse. And the tangent of an angle is equal to the opposite over the adjacent. That's where the SOHCAHTOA comes from. So the question is, how does this all work and why does this all matter and what are we going to do with all of it? So we're going to draw our 30, 60, 90 triangle, the one we've been working with. 30, 60, 90. And we learned from last time that our sides were 1, 2, and square root of 3. We're going to begin by finding the sine, cosine, and tangent of 30. So I'm starting with this angle up here. Starting with 30, with my 30-degree angle. The first thing I want to do is I'm going to label my opposite, my adjacent, and my hypotenuse. Well, the hypotenuse is easy. It's always the one across from the right angle. My adjacent is the one next to it, and my opposite is the one across from it. So my job is to find my sine, cosine, and tangent. Remember, sine, we just learned, was the so it's opposite over hypotenuse. So my opposite side length is 1, and my hypotenuse is 2, so the sine of 30 is equal to 1/2. If you're not sure that that's a true statement, type in your calculator sine of 30, and it's going to give you 1/2. So the cosine of 30, that's our CA, that's our adjacent over our hypotenuse. Our adjacent over our hypotenuse. Our adjacent side we know is square root of 3. Our hypotenuse is 2, so the cosine of 30 is square root of 3 over 2. And the last one we're going to find is our tangent of 30. Tangent is our TOA, which is adjacent side is square root of 3, so our tangent of 30 is 1 over the square root of 3. Okay, so utilizing the same picture, we're going to go ahead and find the sine, cosine, and tangent of 60. So this time we're working with this angle here. So again, first we're going to label our opposite, adjacent, and our hypotenuse. Well, the opposite is the side across from it. Adjacent is the side next to it, and our hypotenuse is always the same. It's our hypotenuse. So thinking back to sine, we learned that sine was the opposite. It's our opposite over hypotenuse. Our opposite side is square root of 3. Our hypotenuse is 2, so the sine of 60 is square root of 3 over 2. Our cosine, that was our CA. That is our adjacent over our hypotenuse. Our adjacent side in this case is 1. Our hypotenuse is 2, so we get 1 over 2. Our tangent was our TOA, our opposite over our adjacent. Our opposite side was square root of 3. Our adjacent side was 1, so tangent of 60 is square root of 3 over 1. Now we're going to do the 45, 45, 90. So I've now drawn a 45, 45, 90 triangle. And if you'll recall, our sides were 1, 1, and square root of 2. It does not matter which 45-degree angle I pick, so I'm going to go with this one. And I'm going to first label my opposite, my adjacent, and my hypotenuse. The opposite is the side across from it. Adjacent is the side next to the angle, and the hypotenuse is always across from the diagonal, or is the diagonal across from the right angle. So my sine of 45, remember sine is the opposite over the hypotenuse. My opposite side is 1. My hypotenuse is square root of 2. So my sine of 45 is 1 over square root of 2. My cosine is my adjacent over my hypotenuse. My adjacent side is 1. My hypotenuse is square root of 2. So my cosine is 1 over square root of 2. And lastly, my tangent, my TOA, is my opposite over my adjacent. My opposite is 1. My adjacent is 1, so it's just 1 over 1. They've given you, again, your formulas here, your trig functions. So this is our our ka, and our toa. It's our SOHCAHTOA. So number 1 says, what is the sine of 30? So that means I'm starting here. My sine is my So that means I need my opposite over my hypotenuse. So my opposite would be 7. My hypotenuse would be 14. 7 over 14 reduces to 1/2. So my sine of 30 is 1/2. It also asked me for the tangent of 60. So I'm starting here. My tangent is my TOA. That's my opposite over my adjacent. My opposite in this case is 7 square root of 3. My adjacent, which is right next to it, is 7. Whenever I have the same thing on top and bottom, they cancel and I'm left with just square root of 3. For questions 4 through 7, I'm supposed to use the picture they give me here. So 5 says, what is the cosine of 40? Remember, cosine is our ka. That means we need our adjacent over our hypotenuse. So here's 40. Adjacent means the side next to, but not the hypotenuse, which would be 7.66. And my hypotenuse would be 10. So this would be my answer. And I'm going to leave it like that. I'm not even going to divide it. For 7, it asks me for the tangent of 40. Remember, tangent is your TOA. So you need your opposite over your adjacent. Well, my opposite would be the side across from it, which is 6.43. My adjacent is the side next to it, not the hypotenuse, so 7.66. This would be my ratio. I'm going to leave it like that. Lastly, 9 asking for the cosine of A. Cosine is my ka. So I need my adjacent over my hypotenuse. Here's angle A. The adjacent side, the side next to it that's not the hypotenuse, is 12. My hypotenuse is 13, so my ratio would be 12 over 13. So good luck on your last quiz.